So class, welcome to the lecture number 12th of the course Power Station Practice. In the previous lecture, lecture number 11th, we discussed about we solved two numerical problems. So at the beginning of the lecture, I told you what is the advantages of higher load factor. So I deliberately didn't means initiated that topic again, because it is that topic will again be covered in your unit number 3rd. But still one numerical problem was based on the same problem. So the problem was, if you you are given a total annual consumption of a customer, so which is 1500 into 10 raised power 3 units, means 1500 into 10 raised power 3 kilowatt hour, and the annual load factor is 40%. Okay, so you are given total unit consumed and load factor. First, from the total unit consumed, you will calculate the average load, which is nothing but the unit consumed divided by the hours in a year. Okay, so from there you will get average load, and since you calculated the average load and you have the load factor, you will calculate the maximum demand. Okay, so you calculated what is the maximum demand when the load factor was 40% and itne units was 1500 into 10 power 3 units were consumed annually by a consumer. Okay, now the problem is that what will be the saving in the average unit cost if the load factor improves to 100%. Means, keeping the number of units same, what we are doing, we are saying instead of 40%, we increase the load factor to 100%, and we will see what is the saving in average unit cost, means what is the saving in cost per kilowatt hour of energy if the load factor improves to 100. Okay, and how we have calculated this tariff? It is given by the two-part tariff is rupees 500 per kilowatt of maximum demand per year plus 40 paisa per kilowatt year. Means you will say that total charges or annual charges will be 500 rupees per kilowatt of maximum demand. So what you will do, you will calculate maximum demand in both the cases. Here load factor was 40 and here load factor was 100. So these are the number of units. So number of units divided by total number of hours in a year, you will get the average load. So from you have the average load and load factors. So you will calculate maximum demand here and maximum demand here. So then you will calculate the consumption average total annual bill. So it will be 500 multiplied by the load factor, 500 multiplied by the maximum demand plus 40 paisa multiplied by the total number of unit consumed. Since you will have two maximum demands corresponding to the load factor of 40% and 100%, so you will get two annual bills. Okay, so what will you do? You have two annual bills, one annual bill for load factor of 40% and second annual bill for load factor of 100%. Then you will calculate for 40% what is the cost per unit of this energy consumption, and similarly for 100% you will calculate the cost per unit of energy consumption. Okay, obviously the cost here will be very, very small as compared to the cost here. Okay, so then what will you do after that? Then you will calculate the saving. Okay, whatever cost is here minus whatever the cost is here, so that will give you the saving in the average unit cost. Okay, so though I have solved this problem here, but I want you to solve this problem, and you will see the cost here will be cheaper. Means when we are improving the load factor, we are increasing the load factor from 40 to 100, the cost will be reduced because the maximum demand will reduce. Okay, so now in the next so this is your homework. So this question is your homework, and I will give you the answer. What is the answer for this question? The saving will be 8.5 paisa per kilowatt hour. The answer will be 8.5 paisa per kilowatt hour. Okay, so this is your answer. Try to solve this at home, and I will check this means if the university resumes in the offline mode, hopefully after the vacation, and then I will check this answer. Okay, so now let us come to unit number 2. Okay, unit number 2. So unit number 2 is related to economics of generation. What do you mean by economics? Economics means to make profit. Okay, I will say economics by economy I mean that how I can make profit. So economics of generation in case of this in the field of electricity, I means how I can generate electricity to make profit. Okay, and obviously to make profit means economical, means cheaper. Okay, how I can generate electricity to make the electricity cheaper, and if the electricity is cheaper, obviously it will be beneficial both for the consumer as well as for the utility. So first I will say uh, means any power industry, forget about power industry, any industry or any organization, what is the ultimate aim? Ultimate aim is to means attain the maximum economical benefit. Okay, or I can say the ultimate game is to means achieve overall economy, to achieve the overall economy. So I will say, and whose job is this to in case of a power industry, whose job is to means ensure that the system is economical? It is the job of the company which is generating power. Okay, so I will say that it is the job of the utility or responsibility of the utility to design. Firstly, the utility prepare a plan, a design, and then it will build the plant. Okay, so I will say it is the responsibility of the utility to design and build a plant. Okay, in a way that overall economy is achieved. Okay, overall economy is achieved. Got it? So why this overall economy is important? Okay, because if we say that the overall economy is achieved,